Okay, good morning, everyone. I hope you had a good weekend. I hope you were able to study for the test, which is going to be on Wednesday. Today, we're going to cover 7.7. We'll see if we can get through most of it. And then I'll talk about the review if we have time at the end of class. I sent out the review Friday? I don't remember. Thursday or Friday. And I've started working on the key for that. Let me see where I am on that. I'm on number 13. So I've got some of the key done. I kind of just tried to squeeze all the work onto the review itself. So it's kind of sloppy, but I'll finish that up and then I'll send that out later today, probably before 1 o'clock. And then as far as what we're doing, we're going to do lecture today. Wednesday's all test, and then we have spring break. So we won't meet again until the 15th. So we'll meet on the 3rd for the test, and then we will meet again on the 15th. All right. So for the test, just so everyone is clear on what the expectation is, you will come into the class. Everyone will come in, everyone will turn their videos on, and I'll be checking to make sure that your cameras are set up properly so that I can see you and your entire workspace. So I've already discussed this. I'm just going to say it one last time. So I recommend that you download Zoom on your phone and then use your phone as your camera, and make sure that you have a power cable to plug into your phone so it doesn't die during the test. And so what you'll do is you'll just set up your camera, and what I need to be able to see is like what you can see here on my camera. All right, so I need to see a desk. I need to see what's in front of you, okay? So it's important that I see, this camera is actually not that great. I would want it to be slightly turned so that, well, I'm not gonna mess with it because I like my camera where it is, but slightly turned so I can see, if there's a wall in front of you, if there's nothing in front of you, I need to see that. And so we'll spend the first few minutes just getting everybody's camera set up, and I'll just say, okay, Allison, your camera's good, Michael, your camera's good, and I'll just make sure everyone's good. And once that's set up, then at that point, I will, in the chat, I will send everyone a link, and you click on that link and you'll be able to download the exam from that link. Okay, so you can do that on your computer screen, okay, or whatever you're using for Zoom. Download the test, and then we'll take 10 minutes, maybe 15 minutes for everybody to get out paper and copy down all the problems. All right, so you'll have to hand copy the problems. It kind of sucks, but that's what you have to do. If you have a printer, it's fine if you print it out. Okay, so you just go to your printer and print it out. But I can't require people to have a printer, so I have to give everyone 15 minutes to write down the problems. Then once the problems are written down, then I will officially start the test, and that's the point where you have to get your camera set up and make sure there's not a computer on in front of you. So you can't use a computer during the test. Okay, you can't be looking off a computer screen to look at the problems. Everything should be on paper, and then you're just going to do everything, write all your work down. Any questions up to this point? Okay.
Just real quick, is the test going to cover 7.7?
What's that?
Is the test going to cover 7.7?
No, it is not.
Okay. So
It is not. Yeah.
until...
I put it here. Maybe you didn't see it. So 7.7 will not be on the exam. All right. So what's that?
I have a question.
Yes.
Will those sheets that you gave us be allowed on the exam?
Yeah, so okay. So once you start taking the test, well, once we start the test, what I will say is, okay, everybody go to your camera and put your papers up to the camera one by one, both sides, and everyone's going to show me what they have. All right. And so what you're allowed to have is blank paper. Okay, you can't use a spiral or a folder. Everything's got to be separated out. So tear paper out or whatever. It should just be a stack of blank paper, maybe 10 sheets or so. just so you have enough. You'll have the exam that you just hand wrote, and then you will have your formula sheets. Now, the formula sheets are everything that I have provided for you on Canvas. You cannot have your own formula sheets that you created on your own or from some other class. Everybody's got to be playing this game with the same resources, all right? Now, those formula sheets, I told you in the beginning, you have to print those out. You have to somehow get those. So if you don't have those yet, then you might want to spend the next 2 days either finding a printer, or you can hand write all the formulas off the formula sheet and create your own formula sheet. But it can only be stuff that is on Canvas. So let me show you what I mean by that. And I'm just going to tell you that this first test is going to take us a while to get it going. All right, because there's always going to be someone who can't get their camera set up properly. The next test will go much smoother. All right, so just be prepared to be frustrated with one of your classmates because they can't seem to get it right. All right, it's going to happen. All right, so try not to be that person that I'm sitting there saying your camera is still not right. Look at everybody else's camera. That's what we want. All right, so on our Canvas page, go into Files, and then I have the 2412 formulas that you're allowed to have. So these are the formulas that are provided at the back of the book. Okay, you can have those. It's what, 3 pages? But then in addition to that, if you would like to, you can have the formulas that come from the calculus book, which has more stuff here and a bunch of stuff you don't need. You're allowed to have all 6 of those. So you can have a total of 9 formula sheets for the test. And if you look at those sheets, there is no unit circle. Okay, so there is no circle with all the common angles and points. There's none of that is provided. So that's something you have to have up here. And so, you know, if you're like me, I'm not big on memorizing. Once I start the test officially, if you just want to write down and draw your own, like maybe just the first quadrant of the unit circle, you can do that. You just can't have that before the test starts. That makes sense?
I have a question.
Yes.
Does the calculus formula sheet include everything on the 2412 formula sheet
I have
and
looked
more,
to
or
see.
just separate?
I have not looked to see what, you know, like comparatively. Yeah, I'd have to look through. That would take me a little while. So I would just, if I were you, I would look at them and see if there's anything on the pre-cal, the 2412 formulas that's not on the 2413. And then maybe you just need one of them. Maybe you just need the calculus ones. I would say you probably just need the calculus ones, but you know, yeah. Anything else?
How the review is set up, is that how the test is going to look like?
I think the review is longer than the test is going to be. So you have to remember, we only have an hour and 40 minutes for the test. And we're probably going to eat up the first 20 minutes, 25 minutes, just getting everything going. So I can't possibly ask you to do something that can't be, you know, finished in an hour and 20 minutes or so. So it won't be as long as the review, but topic wise, it will cover stuff that's on the review. So my thought is, if you can do the review, then you should be okay with the test. Now, when the test ends, okay, oh, and by the way, during the test, everyone's going to be muted. You will be allowed to, you know, you can listen to music or whatever, that's fine. But if during the test, I need to interrupt the test and say, hey, everyone, you know, number 5, there's a typo, you just need to be able to hear me, all right? So listen to music, that's fine, but still have the ability to hear me if you need to. Now, when the test is over, meaning when you are done with the test, what will happen is you will go to the chat in Zoom and you will just send me a chat, not the whole class. You'll just send me a chat that says, I'm done. All right. Now, this is very important. You'll say, I'm done. And I probably won't even reply to you. Once you say you're done, then you can leave the Zoom session. all right? You can leave. Now, from that point that you say I'm done, you have 15 minutes to get the exam to me. Now, I will send you an email tomorrow before the test that will have a link. It'll be through our Canvas email. It will have a link, and when you click on it, it will ask you to upload the exam. So you have 15 minutes from when you say I'm done to somehow either scan your work, you know, if you have a scanner at home, or what most people do is they take pictures of their work with their phone. And the important thing, and we've had time to practice this, is that you send me all of your pages of work. I don't need your formula sheets. I don't need all that. I just need your work. I need all of those pages nice and clean and in order. And I need that sent to me as a single PDF file. Okay, a single file, not a JPEG, not a picture file, a PDF file. So there's most of you have iPhones, so most people use Cam Scanner. I don't know, I don't have an iPhone, so. But again, we've had I've given you an opportunity to try this, and some of you have, some of you haven't. So we'll see how it works out. But if you can't get me a single file, I'll probably on this test just penalize you. But on exam 2, I won't even accept it. All right. So would you all like to see what it looks like? I had my other class turn it in. Let me show you. I'll bring this up so you can see it.
So
I
on a
hate to
Google
waste
Doc,
this much time. Go ahead.
on a Google Doc, you can upload pictures into it and then save it as a PDF.
In Google Docs.
Yes.
Okay.
So that's
Good.
another way you could do it if you didn't have the Cam Scanner app or whatever. But
Okay.
that's probably how I'm going to do it, is just upload the pictures into a Google Doc and then save it as a PDF and submit it that way.
Okay.
But yeah,
Great.
that's one way you can do it.
Okay, good. Thanks for sharing that. So remember, because you're logging off, like after you're done with the exam, you have 15 minutes. You can be using your computer and your phone and sending files from your phone to your computer. So there's a bunch of different things you can do, but you have to do it in 15 minutes. So, you know, I won't accept it an hour later, because then theoretically in that hour you could have been trying to get answers from someone else, you know, so we have to kind of keep it reasonable. Let me show you. This is my.
Is there a specific way you'd like the PDF titled?
Nope, just, you know, your name would be great. When you go to upload the file to me, I'm using Dropbox, and when you upload it, it's going to ask you for your name. So just put your name in. So you can even forget to put your name on your test, and I should still know who you are. So here's my Cal 1 students that just took a test, and they did really good. I only had one student not get it right. Where's the student that didn't get it right? I want to show you the student that didn't get it right. Where is it? Oh, no. Where is it? Oh, here it is. Okay. So I'll show you the student that didn't get it right first. So they sent me 2 files. So that was the first file, which was the last page. And then they sent me another file, which was another page. So that wasn't too big of a deal, because it was 2 PDFs instead of 1. The student who really kind of messed it up was, oh, this one. Okay, so to give you an idea of this was sent to me. Okay, can y'all see that? Can y'all see it? Can y'all read that work?
No, it's
Neither can I. All right. So even when I zoom in on this, it's really not good. So this is a JPEG. This is what a picture of 5 pages or 4 pages looks like to me. And I can't grade that. So that's why it's important to send it as a single PDF file. So I'll show you, here's one that was done correctly. Let me try and pull someone up that did decent on the test. I think, yeah, this one. So here's one. So there we go. So nice, clean PDF, single file, 3 pages, very easy for me to read. I can zoom in, I can see things. Okay, so what I do is I grade these, right? And I grade them by hand. And So this one, oops, this came out sideways, but see, I grade them by hand, and then I will send that back to you as a single file. So when I post your grades, you'll get a copy of your graded exam, and that way you know what like you got wrong and right and stuff like that. All right. So anyways, I hope that that helps you see why it's important for me to get a single PDF. You know, if each of you sent me 8 files and there's like 20 of you, then I'm going to have 80 or so, you know, right? Or what, more than that, whatever, doesn't matter, right? A lot. I'll have a lot of things that I have to merge together, and it just takes forever. So, okay. So you will send me your thing after 15 minutes, and that's it. Now, if you are a student who gets to the end of the class and you're still not done, then I will call time. And then at that point, that'll be at what, 10:40? I'll probably go to 10:45. I can't go any further because people might have another class to get to. So at 10:45, I'll stop the test. At that point, I'm just going to say, hey, whoever's here, I'm ending the session, and I'll end the Zoom session. Everybody has till what, 10:45, 15 minutes. Everyone will have till 11 to get me the exam. And when I go to Dropbox and I look at the files that I've requested, like here's the test that I just showed you a second ago. It shows me when they were uploaded. Okay, so I have the deadline here for these students was 3 o'clock. So I had one student get a little late, but she let me know that she was having some issues, so I was okay with it. So I can see, and if you don't get it to me on time, then that'll be an issue. All right, any questions on that? No? Boy, I miss just handing everyone a test. It's so much easier.
Okay, wait, real quick. I do have a question.
Uh-huh.
So we're not going to submit it through Canvas?
Nope.
Okay,
Nope.
Dropbox.
No, here's what'll happen. Yeah, I'll just show you this way. I'm going to just show you what I sent my other class so that you can see what it looked like. So I sent, here we go. This is exactly what I sent to my other class. It said, when you finish your exam, please click here and upload the exam. So they'll click on that, brings you here, and it just says, you know, this was 2413, Tuesday, Thursday class, exam 1. It says add files, right? So so now you've got your Google Doc or whatever saved as a PDF. You've got that on your computer. You just hit add files from your computer, right? Files from your computer, click that. And then you just go browse and get your file and drop it in there.
Okay, thank you for showing that.
Yeah, I'll show you. Let me go ahead and just do this. So I drop it, and then thought it asked for a name. Oh, I'm already signed into Dropbox, so it's not asking me who I am. But if you don't have a Dropbox account, it's probably just going to ask you who you are, and then you upload it, and that's it. You're done. Okay. All right. Anything else? I think the camera is the most important thing. All right. The camera is the most important thing. So unfortunately, I had a student in my Cal 1 class the other day that had to sit on the floor and have a camera set up so I could see their entire workspace, because they just, for some reason, could not get things set up. And that was the only thing that worked. So I don't want someone to have to sit on the floor. So make sure you, like, before the test, like, turn your camera on and like try this out. Okay. Like, look at the, you know, is it going to be your work area? You know, calculator. I've already said you can't use your phone on the test as a calculator. So everyone needs to have a scientific calculator, right, for the test. All right. I think we're ready to get to today's material. Yes. Anything else? All right. Okay. So today we are last class, what we did is we looked at the graph of sine and cosine, right? And we talked about how we can change the amplitude, and then we can change this omega thing that changed the frequency. And we practiced graphing a few of those, right? And then in the homework, I really wasn't a big fan of the homework, the way the system did it, because To do it in the system, if you did your homework, you probably noticed you don't have to do like the 5 points. You could kind of get away without doing those 5 points. Did y'all notice that?
Yes, I noticed it.
Yeah, and see, on your test, I'm going to want the 5 points. So I didn't really think that that was a good, but that's the way the computer system works for those problems. So I just don't want you to come into the test on Wednesday and think that I've asked you to graph a sine function that you're going to be sitting there doing the same thing you did on the online homework. So just follow through with what we did in class last time, which is, you know, when you're sketching these, figuring out what your period is, and then finding out what, you know, what halfway is, and then what halfway between those is, and then plotting your points and drawing. That's what I'm going to want on the test. Okay, so we did sine and cosine, and today we're going to try, I don't know how much time we'll have, but we're going to try and graph the other 4, right? Because we have sine, cosine, tangent. Those are your basic 3. And then we have all of their reciprocals, right? So where we're going to start, we're actually going to not start with tangent. We're going to start with let's do cosecant first, all right? So our goal here right now, or in the immediate future here, is to try and graph. Our goal is to, I'll say sketch the function f of x equals cosecant x. Now, remember, the definition of cosecant is that it is the reciprocal of sine. So we know that this is 1 over sine of x. So that means that because cosecant is just the reciprocal of sine, to graph cosecant means that we need to know a lot about what sine's doing, right? So it's just the reciprocal. So if you think about it this way, if we create a t-table where we plug in values of x, and let's go back to what we already know, sine x, notice I'm not doing cosecant, I'm just doing sine. We know what the sine function does at the common angles. Well, I expect that you would know. So we know that sine of 0 is 0. Let's just use pi over 4. We know that at pi over 4, we plug that in, we get root 2 over 2. We know at pi over 2, we know that sine is 1, right? So this is all coming off of the idea of the unit circle. When we're looking at these different angles like 0, we're looking at the y-coordinate because it's sine. There it's 0. Here the y-coordinate is root 2 over 2. When we go to pi over 2, which is straight up, we know that the y-coordinate is 1, and so on and so forth. We could just keep going around, right? So now if we extend this kind of table and we think about what cosecant would be, it would just be the reciprocals, right? It would be just the reciprocals of this. Y'all agree with that? It would just be the reciprocals. So let's try and do that. Okay, let's just take these answers and do 1 over them. And do y'all see immediately we have a problem? That if we try and plug 0 into cosecant, that's really just taking this answer and doing 1 divided by that. And 1 divided by 0 is a problem, right? That's undefined. So we already have an issue with the cosecant function. It's undefined at 0. So remember when we were talking about domains and ranges and things like that, when we talked about sine and cosine, the domain was everything, right? We could plug anything we want into sine and cosine. But right away with cosecant, we see we have a problem at least at 0. Let's keep going here. If you get on your calculator, let's figure out what square root of 2 over 2 is as a decimal. Square root of 2 divided by 2 is about 0.707, okay? 0.707. So if I do 1 divided by that, I get about 1.4. It's about 1.41, something like that. So if I plug in pi over 4, I actually do have an answer for cosecant. And then if we plug in pi over 2, let's see, that'll be 1 over 1, which is just 1. And then I could keep doing this, couldn't I? Just keep on going. So can anyone tell me where we would have our next problem? where would we get 0 here again? We know it's
We'd
0.
get it back at
Pi.
270.
We're looking at the y coordinate. Be careful. Where would our y coordinate be 0 again on the unit circle here?
At pi,
At-
180 degrees.
180 or pi. See, here we have -1, 0. And so that here's where we would have another issue, right? So it looks like, let me just complete this. This was pi over 4, pi over 2, 3 pi over 4. That would be this angle here. That would give me √2/2 again on sine. And so the reciprocal of that, 1 over that, 0.707 would be the same thing we got above, which is 1.41. But then when we got to pi, that's where we would get 0, and that would be undefined. Are y'all following this? Okay, so we could sit here and make a table all day long, but it really doesn't help us see what the picture of it looks like. And that's the important thing for us. So I threw together something this morning that might help us see this. Okay, I hope that that's big enough for everyone to see. So what we're looking at here is just our standard sine function, all right? This is just our standard sine function, right? Sine of 0, 0, or I should maybe say it this way. Remember with the sine function, we had, the period was 2 pi, right? So we have 3 important points here. Those are our x-intercepts. And then we had a peak and we had a valley. Those were our 5 important points. So this is our sine function. What I'd like for us to look at now is what cosecant looks like. So remember we said at 0 it was undefined. So when I try and plug 0 in, I should get nothing. Now what I've done is I've created something where I can just drag a point across and it's going to spit out the answer. So I'm going to go to pi over 4. Remember at pi over 4, sine was 0.707, but then 1 over that was 1.414, right? And then when we got to pi over 2, sine was 1, but so was cosecant. So let me move that over. So you see at 1, we're at 1 on both. And then when we moved to 3 pi over 4, we are at 0.707 again, which gave us 1.414 again. So do you see this green is a graph of the cosecant function? It's just all of these red values, it's 1 divided by those. And so let me keep going. At pi, we were going to be undefined, but I want you to pay attention to what's happening to this cosecant function. This is a critical thing I'm trying to point out here. If we watch this, what the sine function does here, the sine function is getting smaller and smaller, right? These y values, those are all getting close to 0, right? Well, let me say it this way. They're just getting smaller. How about that? They're smaller and they're also all positive numbers. So these are becoming small positive numbers. So if you take a small positive number, right, and you take that and you put it in the denominator, you know, you put 1 over it, 1 over a small positive, what are you going to get? 1 divided by a small positive number should give you a what? What type of number would you get? Big or small? Think about it
You
this way.
get a larger number.
Yeah, if I take the number 1, and let's say I divide it by 0.5. Okay, if I did that on my calculator, 1 divided by 0.5, I get 2. Okay, now let me try 1 divided by a smaller number like 0.1. If I do that, I'm going to get 10. Let me go with a smaller number, 1 divided by 0.01. That's going to give me 100. Let me go 1 divided by 0.001. That's going to give me 1,000. Now, this is a huge thing to understand. All right, this is what a lot of calculus is about, is understanding how numbers work together. So what I'm trying to get you to see here is if you ever take a number on top, like a number 1, that's kind of a fixed number. It's not changing, right? That's fixed. And you start dividing it by smaller and smaller and smaller numbers, this is going to start to become a big positive number. So as we start to draw this graph, right, sine is starting to become small positive numbers. which means the reciprocal cosecant should start to become large positive numbers, right? So watch the behavior of this green graph as I start to move to the side here. See how it's starting to go up and up and up? Well, it's off the chart there. There we go. Okay, so it's up, it's gone up, but remember what happened at pi? At pi it was undefined, wasn't it? Wasn't it undefined?
Yes, sir.
So
So-
does that mean there's a vertical asymptote there?
That's exactly what it means. That is exactly what it means. There is a vertical asymptote there. So it almost looks like this cosecant function almost looks like a parabola. It's not a parabola. So you got to remember something about parabolas. Parabolas, when they open, they go to the right and they keep going to the right. Even though they're going up, they're still going to the right forever. And then to the left, they go to the left and they go up, but they keep kind of spreading out. This cosecant function, the one here in green, is like a parabola, but it's stuck. It's stuck between, at pi, there's a vertical asymptote, and at 0, there was a vertical asymptote. So it's like a parabola that's stuck between two walls, and it keeps going up and up. All right? That makes sense? Okay, now let's look at what happens over on the other side. I want to clear all this stuff out. So look at what's happening here. We have right now the sine function in red. Do y'all agree that that is a small negative number, right? That's a small negative number. And if we take 1 and we divide it by a small negative number, what should that give us?
A smaller number?
Is it smaller? Take 1 and divide it by a small negative number, and you should get a big negative number. Try it yourself. 1 divided, let's go with the small number, negative 0.01. If you did that on your calculator, you get negative 100. So if you have 1 divided by a small negative, you should get a big negative. So we should be able to see this here in a minute as the graph starts to come in. Here it's coming. Okay, so let's look at this. Again, trying to understand here what's happening. We know that at pi, right, at pi, cosecant is undefined, which is why we have this vertical asymptote. But as soon as you get to the other side right here and you start plugging in numbers like this, these are all small negative numbers. And so the reciprocal of those should give you very big negative numbers. Those points are way off the graph down here. And as these numbers get more negative, then it starts to come back because see, they're getting bigger negative until you get to negative 1. And once you get to negative 1 on the sine function, 1 over negative 1 is still negative 1. And that's why the green and the red graphs come together here. And as I move to the right, sine is going to be negative, but it's going to be getting smaller and smaller. So we should see the green one start to take off, which is exactly what it does. Takes off the other way. Until we get to 2 pi. When we get to 2 pi, now we have another vertical asymptote. So, okay, that was just to try and get you to get a feel for what's happening here. Now what I'd like to do is I'd like to go to that graphing software Desmos. And I'm just going to type in sine x, keep it simple. There's the sine function. Here's the cosecant function. There we go. All right. So the blue is the cosecant and the red is the sine function. So do y'all see that everywhere that we have a, let me do it this way. Everywhere that the sine function has an x-intercept, right? Everywhere that we have that, do you see that that corresponds to these vertical asymptotes, these vertical barriers? Happens at every x-intercept, right? And then in between each of these vertical asymptotes, in between, we have these parabolas, and they're either going to be like I don't want to, they're not parabolas, okay? They look like parabolas. We have these little U-shaped pieces that are either going up or going down. And they always touch at these points, right? Those points, let me do a different color. At these black points, we always touch. That's where the sine and the cosecant come together. So does anyone have a question about why it looks that way, or does it make sense to you why the cosecant would be like that? So I'm gonna say this one last time. Looking at the red sine function here, as the sine gets smaller, right? See these y values are getting smaller. The cosecant is taking off to infinity. As the sine values get smaller here, the cosecant function is taking off to infinity because it's the reciprocal. And then on the other side, as these sine values are getting smaller but negative, the cosecant function takes off to negative infinity. So it starts to get really big but negative. And then same thing here, it gets really big negative. And so just want you to try to wrap your head around why the shape looks the way it does. All right, with all of that said, if we want to graph a cosecant function, then what do you think we should do? Like if somebody gives you a cosecant function, says graph it, what do you think you should do?
You should graph the sine function first.
Yeah, why don't we just graph the sine function and then just use what we just said the properties are, right? That's the way we're going to do it. So that's why there's not a whole lot of new stuff here for graphing cosecant, because to graph cosecant, all we're really going to do is graph sine and then just change the picture a little bit. So good, Cameron. Here we go. Let's do an example. Hope this makes sense, everyone. Does anyone have any questions? Well, before we do our first example?
What would the domain be? Like, how would we write that?
Yeah, let's do that. Let's graph it first, then we'll talk about domain and range. Okay, so let's sketch the function f of x equals 2 cosecant of 4x. So this is a cosecant function, right? We have to recognize it's cosecant, and that means it's the reciprocal of sine. So now what we're going to do is this. We're going to just say, okay, pause, hold on. Why don't we do this instead? Let's sketch another function. I'll call it g. Let's sketch the function to sine of 4x. If we graph this, which is just basically this thing here with, just replacing that with sine, then whatever that looks like, we should be able to use it to draw our vertical asymptotes and then draw our little U-shaped things, and then we'll be done, right? So now you have to go off of what we learned last class. So somebody want to help me identify what the amplitude and period of this are?
The amplitude is
2. Okay, so the amplitude is 2. That's just taking that number there and taking its absolute value, which is just 2. And then how do we get the period?
2 pi over 4.
2 pi over 4. It's always 2 pi, right? You always take 2 pi and divide it by the number that's in front of x here, which in this case was 4. So we just get pi over 2. Okay, good. Now you have a test on this in 48 hours, right? So let's call on someone. And you know what? I'm going to pause the video real quick. I want to tell y'all something. All right, so let's see who have I not called on in a while. It's James. It says I haven't called on you in a while.
Oh, yes, sir.
But you seem to always respond. But I'll put you on the spot anyway because I think you can handle it.
Okay.
Okay, so when we go to graph the sine function, right? We find out what the amplitude and period is. How would you proceed from here?
After we do that, so after we find the amplitude and the period, we would have to set it up into a equation,
Okay.
and then we would hold on. I know how to do this. Hold on.
Okay.
Um,
I trust that you know, but in an effort to try and get through and expedite the class, unless you're ready to go now.
oh, okay, yes, sir. So what we'll need to do is um
So look, I'm gonna let you get organized there.
okay.
All right. But again, as a message to the whole class, what you want to be, where you want to be in 48 hours is that when you go to graph sine, it's in your mind, it's amplitude, period, draw a picture, find my 5 points, 5 points, draw the picture. That it should be that. It shouldn't be, I know, you know, it shouldn't be like where you have to figure that out and take 5 minutes to do that. So James, I mean, I know you probably can do this, but you want to just get to that point. And that goes for sine and cosine.
Oh, yes,
You
sir.
go to graph both of them. Amplitude, period, 5 points, draw your picture.
Okay, I'm ready. So, with it being said, we're not gonna have to flip it over the X or the Y because
That's
it's
right.
positive. It's gonna be a vertical shift of up 4 because of the 4.
The 4 is next to the X.
Oh, yeah, yeah. So,
If it was out here, if it was +4 out here, it would move it up 4. But it's not on the outside, it's in front of the X. So all that impacts is your period.
and then for the period, it's gonna just be the pi over 4 or the 2 pi over 4
Mhm.
equals pi over 2, and then after that we would just really set up our equation.
So when I put, we know that it's going to start at 0, and we know it's going to go to pi over 2. So we then have to go and find halfway in between,
The midpoint, yeah.
midpoint, which we just add these two together and divide by 2, right? We take their average.
Yes, sir.
Okay, so I'm not going to go through this part. I'll just write it down what I'm doing, but I'm not going to go through this. This is that divided by 2, you should get pi over 4. And then here, if you do the same thing, you should get pi over 8. And
I
then
have a
here,
quick question.
yes. Mhm.
It doesn't have to go with this problem, but if you were to put like a negative in front of the 2, which means that you have to flip it over the x-axis, right?
Yes.
So would you do that before you move it like vertically up or down?
Yes.
Okay.
Yes, good question. We're going to do more of that in the next sections. There's actually an entire section on basically what we call phase shifts. And so we are going to be working a lot on, right now what we're doing is like stretching it either vertically or horizontally. So an amplitude is a vertical stretch. Your amplitude controls your vertical stretch. The number in front of the X controls your period. So it's like a horizontal stretch. And then what we'll do a lot later is we'll take the whole picture and then we'll just like move it left and right, or we'll move it like up and down. Those are called, well, phase shift is left and right, and then the other shifting is up and down. We've seen a little bit of up and down, but it will always come after the stretching and flipping. It's kind of like order of operations. Okay, so we've got this, we've got our amplitude here, we've got our 5 important points are ready to go. We have to remember that a sine function has an x-intercept at 0 and at the end and in the middle. We have to know that, right? We have to know that's what a sine function looks like. We have to know that the peak happens at the first quarter mark at the top, and then the peak on the bottom happens at the 3/4 mark. And then it just looks like a sine curve. So it looks like a frown, and then it looks like a smile. I'm doing it dotted. The reason I'm doing it dotted because this is not our final picture, right? We're trying to graph cosecant. We're trying to graph 2 cosecant 4x. So in order to graph that, I've got to get the sine function in place first. And now at this point, let's write what we know about the cosecant. And that is everywhere that we have x-intercepts, everywhere we have x-intercepts. So Young, are you there? Yes. I thought I heard So Young. So Young, no? Oh, there you are. Are you with us, So Young? I can't hear you, so I'm going to move on. Caroline,
Yes, sir.
everywhere that sine has an x-intercept, cosecant will have what?
An x-intercept?
Everywhere that
Like-
sine has an x-intercept, cosecant will have a what? Its reciprocal function will have what?
A negative x?
So, let me have you think about it this way. Everywhere that the sine function hits the x-axis, what's the value of the sine function?
Oh, so you're talking about where it is at pi over 4 and pi over 2?
At zero, pi over 4, and pi over 2, the sine function's value is 0, isn't it? That's what the x-intercept means,
Okay.
right? Do you agree? You sure? That looks like just a nod of like a agreement.
I mean, I'm a little rough on this part, but
Okay, so when you say that anytime a function has an x-intercept, you're telling me where the function's value is 0, where the output is 0, right?
for
So if you plug in 0, you get 0. If you plug in pi over 4 into the sine function, you get 0. If you plug in pi over 2 into this, you get 0, right?
mhm.
Now, the cosecant function is the reciprocal of that. It's 1 over that, right? Which means that everywhere that this sine function has an x-intercept, the cosecant function should have what? 1 over 0, right?
1 over 0,
Which is
undefined.
undefined, and that was the, you remember the picture? What did the picture look like of cosecant? Where'd it go? Where's my picture? I thought I had a good picture.
So
Oh,
it's not it's not on the negative side of the x-axis?
let me go back here. I think I got rid of it. So look at this picture again. Everywhere that this sine function, the one in red, everywhere it has an x-intercept, that corresponds to
Oh, the asymptotes.
the asymptotes of the cosecant function, right? That's an important thing that we all have to understand here. Everywhere your sine function has an x-intercept corresponds to the vertical asymptotes of the cosecant function. So when we've drawn this sine function, what we can now say, now we're actually trying to draw this cosecant function now. So what we do is we say everywhere we have an x-intercept, I'm going to draw a vertical asymptote.
Okay,
Okay.
so question real quick.
Mhm.
So we were given a cosecant function, but we're graphing the sine function. So that would be flipped over so for the cosecant, would it actually be like the smile and then the frown when it's flipped over?
Smile. You mean like here and then here, like that?
Yeah, for cosecant, because aren't we doing the sine right now?
We are doing sine, right? We are doing sine, but the cosecant is not just the flip of sine, it's the inverse, the 1 over it. So we know that cosecant has to look like this blue thing, right? It's just a matter of where things are. That's all it is. It's just trying to figure out where these little U's are going to start and stop. I'm a little concerned because, you know, Caroline's usually like on top of things here. So if Caroline's a little confused, I'm afraid that there's probably a lot of people confused. So just concerned a little right now.
Sir, I have a
Cameron,
question.
you look like you want to say something.
Yeah, I'm not confused. I just want to clarify. If we did the table, we would do the same thing, right? Where we multiply the y values by 2. And like
Mhm.
if we did the x and y table to get the
Mhm.
point, could we do that
Yeah.
as well? It would
Yeah,
just
but
be longer
it's
way.
very inefficient. It's very inefficient to do it that way. We
Okay.
want to be able to sketch these, and we want to be able to sketch them quickly. All right, so the way to quickly sketch these is to do a quick sketch of the sine function, okay, which we've done, right? We did a quick sketch of the sine function.
Mhm.
Once we have that, everywhere we see an x-intercept, we will draw a vertical.
Mhm.
And then it's just a matter of drawing the u's. And I know that these points, this peak and this valley, are also on the cosecant function, which means that the u must go like this, and like this, and then like this, and like this. And the red pictures, or the red parts there, are the graph of cosecant.
Mhm. Okay.
Okay. I'm going to do another one. Trust me. I mean, in what I'm going to hopefully get you to see is that this can be a lot faster if we just can draw that quickly.
Yes,
So
sir. Because I
Go
was
ahead.
taught in the past, like in high school, they actually made it where we had to do the table. So that's why I was just wondering. But no, this is a way quicker way.
Yeah, I think this is faster. Things do get a little weird when we start doing shifting of the cosecant function around. But for now, this is definitely the most efficient way. Let's do another one, okay? Let's put this one away. Let's do another one, and hopefully things will start to come together a little bit. So let's try this one. Let's sketch. Oh, wait, we didn't talk about domain and range. Sorry. So for this problem, this is where things get really weird. The domain, all right? So we cannot have what things plugged in. 0 can't be plugged in, right? Pi over 4 can't be plugged in. Pi over 2 can't be plugged in, right? And remember, this graph continues, right? It goes in both directions forever, which means we have like an infinite number of u's here. You have to remember that. The true picture of cosecant goes in both directions forever, very much like that picture does, right? You just have all these u's. At all the peaks and valleys of sine, you have a bunch of u's. So we need a way to say what the domain is. So let's see. We said I'm going to highlight the things we cannot plug into cosecant right now. The things we cannot plug in 0. We're not plug in pi over 4. We can't plug in pi over 2, right? But there's an infinite number of these. So how am I going to write this answer? This is the challenge. So I want you to think about the unit circle for a moment. And I want you to think about where we would have problems here from this picture. 0 is here, right? That's 0. We try and plug in 0, we have a problem. Pi over 4 is here, right? That's this one. Pi over 2 is here. And it keeps jumping by the same amount each time. Do y'all see that? 0, pi over 4, and then another pi over 4 takes you to pi over 2. So we should have problems at any angles that lie on any of these points. All right. So I need to be able to write this down. Domain. X cannot be equal to, right? It cannot be equal to any of the angles that correspond to these yellow points along the unit circle. So I'll give 3 points bonus on the test you're about to take on Wednesday if somebody can tell me the general solution for all of those points. And I'll give you a hint. You're going to use that, what did we use? N or K? I can't remember if we used N or K. I think we used N.
I thought we used K actually.
We used K? Okay, it was K. So anyone, first person gets it, gets the bonus.
K pi over 4.
K pi over, okay, who said that first? I don't know who said that.
I did.
Okay, Brianna. So Brianna said K pi over 4. Let me write it down. Let's see if that seems right. K pi over 4. Can you explain what you're thinking there, Brianna? It's correct.
Well, when I went over, when you brought up the unit circle, I was looking at it, was like, well, technically when you were talking about breaking it up into like pi over 6 and or pi over 3, whatever it was, and pi over 4, like how to draw it individually.
Yeah, like to jump around.
Right, like that.
Mhm.
When I was thinking about it like that, I was like, well, those are just pi over 4s all the way around. So, And I mean, you could tell it from the graph too.
Yeah, very good, Brianna. See, you get the 3 points. Don't let me forget that. Just write it on your test when you turn it in. Say, oh yeah, you owe me 3 points. Okay, so this is good. So what Brianna's noticing is that all of these points lie on the common multiples of pi over 4, right? This first point is just 0. This is pi over 4. This is 2 pi over 4. And this is what Brianna was saying when we were counting our way around. This is 3 pi over 4. This is 4 pi over 4. This is 5 pi over 4. And we just could keep going, couldn't we? So every one of these yellow dots along the circle is just some multiple of pi over 4. So she said k pi over 4. Another way you could write that is pi over 4 times k. That's the exact same thing, but it might make a little more sense this way. Or you can even put the k in front. K times pi over 4. So if k is 0, you're here. If k is 1, you're here. K is 2, you're here. 3, 4, 5, 6. And this should take you around the circle and give you all infinitely many places where you cannot plug in those values. Remember, the domain is x's that can't be that, right? So that's how you'd write the domain. We will get more practice with this because I know that this is confusing for a lot of students. But I tell you that you need it in Cal 1 and 2 for sure. You've got to understand this concept of general sort of solutions. All right. Okay, what about the range? The range of this. So the range is the output. So let's look at these red functions, or the red function here. Look at the y values. The range is the y values. Do y'all see that anything between 2 and -2, your graph is never in here? Do y'all see that? The graph is never in this blue region at all. Right? Not the cosecant. The sine function is, but not the cosecant. The reciprocal is not in there. The cosecant function is only up here, right? You only get y values out up here and down here. So how could I do that? I'll give 1 point to somebody for this one because it's not as difficult as that first one. And Brianna, sorry, you can't go again. 1 point bonus on the next exam if you can just tell me what this range is. How you'd write it.
Would it be negative infinity to -2 with a bracket, comma, 2 with a bracket to infinity?
Good. I'll give you the
With the
point.
union
There's one thing different I'll put in here, but this is right. So that was Maddie, right? Okay, Maddie. So what Maddie's saying is that if you look at these y values here, the outputs, you're going to get every negative number below 2, -2, sorry. So that's negative infinity to -2. And Maddie included -2 because that point right there actually does exactly hit at -2. So it's from -2, everything down, that's this. And then from 2 on the top up forever. Okay, the range is everything from 2 up. So that's from 2 to infinity. Now, Maddie had said comma here, but we usually use the union symbol instead when we bring 2 intervals together. Okay, if you have questions about this, just pause. If you have questions about domain and range, just pause. Let's do another example. Maybe after we do the next example, it'll make a little more sense. All right, let's do sketch f of x equals -1/4 cosecant of pi x over 3. All right, I'm going to give you about, I don't know, why don't I give you about 5 to 7 minutes to see how far you can get with this on your own. And then once you're done, I'll kind of I'm not going to do breakout groups. I'm just going to let you kind of work it on your own. And then we'll come back and we'll just kind of see where people are. All right. if you're done, then a little challenge question to you would be to try and graph this function. We haven't talked about that yet, but it's the same exact concept. It's just secant instead. So now you're looking at the reciprocal of cosine, not sine. Is Michael Clark here? No. How about Lauren Fernandez? Genesis Yadi? How about Yamna? No Yamna? So Young, I got your text message about your microphone, or your chat, sorry. Okay, I think that that's probably enough time to get us going on this. Jordan, Leal, or is it Leal?
I'm here.
Okay, are you understanding this?
Yeah.
Okay, so let's go with this. What do we do first here? Or what did you do first with this one?
So I got the period first.
Okay, what did you get for that?
6.
Good, so you did 2 pi divided by pi over 3, right? That's weird.
Yes.
So that's the same as 2 pi over 1 times, well, I'll say divided by pi over 3, which is the same as 2 pi over 1 times the reciprocal, and then your pi's canceled and you just get 6, 2 times 3. Good, very good. All right, so you got the period. What did you do after that?
Then I got my 5 points.
Okay,
So I did 0 plus 6 divided by 2
okay,
is 3.
okay. You did 0 here, you did 6, and then you did 3. And then, did you get those yet?
1.5 and 4.5.
1.5 and 4.5, that's fine with me. Okay, good. Now I'm curious what you did next.
So then since it's negative, I had to flip it.
Good, okay. Everyone see that? We have a negative on the 1/4. So the amplitude is 1/4, right? But we're gonna flip it. So did you just like label 1/4 here and negative 1/4 here, something like that?
Yes.
Okay. And then you flipped it. So go ahead, I'll let you keep guiding me here.
So then I went 1.5 and negative 1/4 as a point.
Okay, so did you put the x-intercepts? Like where the sine function hits the x-axis?
Yeah, at 0, 3, and 6.
Okay, good. I always like to start with those. I mean, it's okay if you start with the others, but we know that the sine function has x-intercepts at these 3 points, right? The ends and in the middle. And then the peak normally would have been here, but because it's negative and flipped, you moved it down here, right?
Yes.
And then you did the same thing on 4.5. Normally it would be here, but because it's negative, it flipped up to be up here. Good. All right. Good job, Jordan. I'm going to let you off the hook. So now the graph would be a smile that turns into a frown. And let's see, Michael, are you there, Michael?
Myers?
Myers, yeah, you following this? Did you get this
Yes.
far?
Yeah, I got that part.
Okay, what do you do at this point?
At this point, you look for the domain and range, right?
Well, we need the final picture. This is just a graph of sine. We're trying to graph cosecant, right?
Oh,
So-
it would the 0, 0, 3, and 6. Those are the asymptotes. So like
Good, good. So 0, 3, and 6. We've got asymptotes, vertical asymptotes. Okay, did you draw your U's now?
the U should be at 4.1 going up, and then at 1.5 going down.
Yep, so we've got like a U going like this, and then touching here, and then going like this. Perfect. Good. Good, good, good. All right, now I'm gonna put domain and range, but I'm not gonna test you on domain and range on, well, this isn't even gonna be on your test on Wednesday, but just so we know it, the domain here, and this is a little harder to see, is that X cannot be, okay, so let's see, what can X not be? It can't be 0, right? It can't be 3. It can't be 6. What would be the next number?
9.
9, right? So those are all multiples of 3, aren't they? They're all multiples of 3, so we just write 3K. That's all the multiples of 3. If K is 0, we have 0. If K is 1, we have 3. If K is 2, we have 6. K is 3, we have 9. So that's all the multiples of 3. And then the range would be, let's see, we only have stuff from -1/4 down, and we only have stuff from 1/4 up. So we would say -infinity to -1/4 with a bracket, union with 1/4 to infinity. Does anyone need clarification on the domain and range? Any other just general questions? Okay, sure. All right, so with that said, we are done with cosecant. All right, let's shift our focus to secant now. All right, secant is the reciprocal of cosine, isn't it? Instead of sine. So when we go and we look at this, I'm going to go back to this picture here. Here's the graph of cosine, right? This is our graph of the cosine function. The cosine function is different than the sine function in the sense that the cosine function has 2 x-intercepts. In between 0 and 2 pi, it has 2 x-intercepts. It has a peak, a valley, and a peak, right? At the ends, you have the peak. In the middle, you have the valley. And then at the quarter marks, first quarter and 3/4 marks are where you have your x-intercepts. But because secant of x is 1 over cosine of x, that means that, let's see, Samuel, are you there?
Yes.
So let's see, can you make the connection? Samuel, everywhere that cosine has an x-intercept, right? Oops.
Mm-hmm.
What would be happening with the, oh, I messed it up. Everywhere that cosine has an x-intercept would correspond to secant having a what?
It would have what's it called?
So everywhere on this picture, everywhere that sine, right? Everywhere that sine had an x-intercept, that corresponded to a what on the blue graph?
The infinity? The
Yeah, that
infinite?
vertical asymptote, right?
Yes.
Okay, so what we can say is that everywhere that cosine has an x-intercept, we should have a vertical asymptote for the secant function. Which means that when we draw it, we should have a u that goes like this. Do you see that u, Michael? Do you see how that would work? Does that make sense
So-
to you, Michael? That we have a u here?
So they're both going like inward?
Well, they're
for each
both
other?
going down, right?
Yeah.
And then over here, this is the harder part. This is where they would, both secant and cosine are the same value there. It would go up like this, and then it would go up like this. Let me show you, I'm going to show you a slightly different picture. We'll get back to that. Let me come over here and I'm going to graph cosine x. Okay, and then here's secant x. And I think I want to look at, there we go. Get away. So there we go. So if you look at the cosine function, just one period of cosine looks like this. Goes down, then it goes up. That's one period of cosine, right? Between 0 and 2 pi. It has x-intercepts here and here, which correspond to the vertical asymptotes of the secant function. And then it's just these u's, but do y'all see how this is a little different? Because if we are only looking between 0 and 2 pi, we're only going to see this right side of this u, and we're only going to see the left side of this u. But they actually do continue. What do y'all think? Does that make sense to you? It's the same principle that we used with sine, except we're doing it for cosine.
Right. And for that bonus question, it would have just been flipped over the x-axis, correct?
Yeah, we had a negative, right? Yeah. Yeah. So I'll just do that bonus question right now so that you know whether or not you got it right. So let's just do this one. So I'm gonna go to a new page here. So if we're gonna graph this, what we would do is we'd really just look at the graph of -1/4 cosine of pi x over 3. If we do the work on this, we would know that the amplitude is 1/4, but it's been flipped over the x. And then it has a period, same exact calculation for period. The period would be 6 again. And so when we go to graph it, we would say, all right, we have 6, we have 3, we have 1.5, and we have 4.5. But here's where things are different, because even though we have an amplitude 1/4, -1/4, we're drawing a cosine, not a sine, right? So for cosine, we have to understand that the important x-intercepts are here. And then normally we would have point here on the 2 high points would be at the end and the low point would be in the middle. But because we have flipped it, this point comes up to here. This point comes down to here. And this point comes down to here. So let me get rid of those others then. This is gone. This one went up and that one went down. So this is what our cosine would look like. So it would look like a little bit of a smile turning into a frown, turning into a smile. Any questions on this being the graph of -1/4 cosine of pi x over 3? That's this. Now we're ready to graph the secant function. So to graph the secant, we just go and say, all right, anywhere we have x-intercepts, we have verticals, right? And then I have a u in between those two verticals. And then on these, I can only draw half of the u. So the u is going to come down, and then the u is going to come down here. So the red graph is the graph of what we wanted. Questions? We won't worry about domain and range on this one. All right, would you all like to see another secant, or can I move on to tangent? It's up to you.
Personally, I feel like I have a good understanding of secant.
Yeah.
Yeah, I think I'm good to go to tangent.
Okay. All right, let's try tangent. Tangent's a little weird. All right, tangent's a little weird. So let's go for it. All right. So let's think about tangent. If we are trying to sketch the function f of x equals tangent of x, we need to understand that tangent by definition is the sine function divided by the cosine function, right? So just by looking at this, where would we have problems? Anytime what happens?
We would hit zeros on sine.
Anytime cosine equals 0.
0 and 180.
So if the sine function turns out to be 0, that's okay, right? Because you
It's
can have
anytime
zeros in a
cosine would be
numerator.
0.
You just have to worry about division by 0. Do you agree?
I agree.
Yeah. So really our problems, okay, we will have problems with the tangent function at points where cosine of x equals 0. Anywhere where cosine is 0, we should have a problem. So I'm just going to try and start graphing tangent, okay? Let me try and graph it. Here it is. All right, so think about this. And this will be a question I'm going to ask someone in the class. Let's see, Joshua's already replied today. Cameron's already replied today. Maddie's replied. How about Sierra? Sierra, I don't think we've heard from Sierra today. Are you here? No Sierra. Brianna has already got 3 bonus points. Karen, are you here, Karen? I see Karen.
Yes, I'm here.
Okay. So Karen, help me out with figuring out when is the cosine function 0. So what values of x would cosine be 0? And if you need to, think about the unit circle. And cosine is the x coordinate. So tell me where you're going to have problems, at what angles?
So at 270.
Okay, down here.
And at 90.
At 90, okay. So in terms of radians, not degrees, that would be straight up is pi over 2, right? So if I were to put pi over 2 here, I should have a problem with this graph, right? Because I'm going to get division by 0 here. And then let's see, if that's pi over 2, let's say that this is pi. And let's say that this is 3 pi over 2. That's straight down, 3 pi over 2. So it would be at these 2 points, we would have issues. Do you all agree with that? We should have problems? In fact, what we're going to have are vertical asymptotes. So we know because we get division by 0, we're going to have vertical asymptotes here. The big question becomes, what does it look like in between? Right? Like in between these 2 verticals, what does the tangent function look like? So Joshua said something a moment ago. Joshua was talking about where this would be 0. Now, if sine is 0, we don't have a problem, do we? Like we don't have division by 0. But if sine is 0, then that's where we would have 0 as the output, right? Which would be an x-intercept. So at what values Anne Marie, I know you've replied, but I'll ask you anyway.
Okay.
Anne Marie, where would we have this numerator sine be 0? At what values of x here?
On the x-axis.
Yeah, where would, at what values, what angles would sine be 0?
At 0
Okay,
and
at
pi.
0 and at pi. So what Anne-Marie is saying is that if we're at 0 or pi, right? If we're at 0 or pi, if we plug that in here, sine of 0 would be 0. So we get 0 on top, 0 over anything is going to be 0. And then sine of pi would also give you 0. So these 2 points should be x-intercepts, right? All right, now the hard part is, what does the graph look like to the left of this point and to the right of this point? I'm going to draw it first, and then we'll talk about why it is this. To the right, it's going to be like this. And so it almost looks like it wants to be a parabola, right? But on the left side, it's going to go down to infinity, negative infinity. This is what tangent looks like. Now, let's talk about why. Let's talk about why it is this case. Let me just pick a random point over here. I'm just going to pick some point and put a question mark. And that's going to be an angle that's really close to 3 pi over 2. Now remember where 3 pi over 2 is on our unit circle. That's an angle that's like close to this. Let's just stop here. Somewhere around in here. I have a point here. Do y'all agree? Okay, so whatever this point is, tangent of that point will be the sine, which is the y coordinate, divided by the x coordinate. So think about this point that I have here. Let me erase this, in my way. Think about this point here. It has an x coordinate and it has a y coordinate. We're supposed to be doing the y divided by the x. So let's see, I've gone through almost everyone here. How about Isa? Isa, are you there? No, Isa? Okay, Leslie?
Yes,
Hey, Leslie, are you following this so far?
it's a little bit of a struggle, but I'm trying.
Okay. I'm going to ask you just to consider this point that I've put here. And I want you to think about if I asked you to take the y coordinate and divide it by the x coordinate. Now, you don't know what they are, right? I haven't told you what the y coordinate is and the x coordinate.
Right.
But do you agree, Leslie, that both the x and the y here are negative numbers?
Right.
Okay, because we're in the third quadrant. So we should have a negative number divided by a negative number, which should give us a positive answer, right?
Yes.
Now, think about this, Leslie. Which is bigger, the x coordinate or the y coordinate? So which do we move more on to get to that point? We move to the left, right? And then we move down. Which is more of a movement? The left or the down?
The down.
The down, right? So this y should be a bigger number and the x should be a small number, shouldn't it?
Yeah.
So if you take a big number and divide it by a small number, you get, and I want everyone to think about this, if I take a big number and divide it by a small number, is your answer big or small? So
Big.
take a big number, let's say 10, and divide it by a small number, 0.2, and what do you get?
You're gonna go small number.
10 divided by 0.2?
It's bigger.
Oh, below 1. Yeah, sorry, it'll be bigger.
Yeah, this should be 50. If you flip it around, you do the small divided by the big, that would be a small number. This would be 0.02. So a big number divided by a small number is a big number, right? So Leslie, what we're saying is that if you were to take this point, which means you're taking an angle really close to 3 pi over 2, and you plug it into tangent, it's going to give you a negative over negative, which is positive. It'll give you a big number over a small number, which is going to give you a big number. So you should have a positive big number, which means that's why this point is up here. Do you see that, Leslie?
Yes.
Now, good. Leslie, you're done. Tyler, are you there? No, Tyler? Angelique?
I'm here.
Okay, Angelique. I'm going to ask you to consider another angle. So I'm going to do it in a different color. I'll do it in gray. How about a value that is closer to pi, like something here? So a little bit bigger than pi. So let me do a new circle. New circle here. We're going to take an angle that's a little bit bigger than pi. So that'll put you at a point over here. So Angelique, if I take a point right here and I call it xy, and we're going to do tangent, which means you take the y divided by x. Tell me about the signs of these two points, x and y. What are they?
They're both negative.
Okay, they're both negative. Okay, and you're going to divide them, which means we should get a positive answer. And then you tell me which is bigger in this case. Is the x bigger or is the y bigger?
The x is bigger.
The x is bigger. To get to that point, you got to move a lot to the left. That's your x, and then down just a little bit to the y. So this should be small up here, right? A small y compared to a big X. And Angelique, if you take a small number and divide it by a big number, you should get what?
A small number.
Small number. So something like this, 0.2 over 10 is a small number. And so what we should get is a positive small. And that's why when you go here, you go up just a little bit. Do y'all see that? So if I'm just trying to get you to see why the graph starts to do this. It starts out small positive, and then the closer you get to 3 pi over 2, it goes up and up and up. And when you get to 3 pi over 2, it's undefined. We'll just do one more. If we are over here at a value right here, I don't know what it is. It's a little bit bigger than pi over 2. So I'll draw a new picture. A little bit bigger than pi over 2 is like right in here. Allison, are you there?
Yeah, I'm here.
Okay, Allison, are you kind of following what I've done with these last 2 points?
Yeah.
Okay, so for that point right there, that x and that y, tell me if we're gonna do y over x, tell me about the signs first.
They're both positive.
Sure.
They're both negative. Or the x is negative?
Yep, the x is negative and the y is
Positive.
positive. Okay, so if you now we know that if you do the ratio y divided by x, you have a positive divided by negative, which should be negative, right? So we know we're
Yes.
going to get a negative answer. Now, tell me which one of these is bigger and smaller.
The y is smaller.
So if I move to get there, I've got to move to the left a little bit and then up a lot, right?
Yeah.
So the y should be a big movement, right?
Yeah.
So the y should be big and the x should be small. And if you take a big divided by a small, you get big. So we
Yes.
should have a negative big number, which is why when we plug in a point that's close to pi over 2, a little bigger, we get a very big negative number, which is down here. Okay. That's it. I just want you to understand the basic shape of tangent. Let me go to the graphing software and show you what tangent looks like. Okay, here it is. Now, can you all see, we looked at pi over 2. We said we had a vertical asymptote. And we said at 3 pi over 2, we had a vertical asymptote. But do you see that it just keeps doing the same thing to the right and to the left? It's just the same picture over and over and over.
So cotangent going to go from right to left on the
Yeah,
on the
cotangent is going to
x-intercept?
go like this instead. But it's not going to be happening at pi. That's important. So I don't want to confuse it yet, but it will do something similar. So there we go. There's tangent. It's just a bunch of those weird graphs with a bunch of vertical asymptotes everywhere. Okay, you know what? At this point, I don't think you're ready to do the homework here. We haven't talked about cotangent. We haven't done enough. We haven't even really done an example of tangent yet. So tangent is very different than cosecant and secant in terms of how you go about graphing it. You don't do 5 points and all that. You do something different. So we don't have enough time to get into that right now. So I think what I'm gonna do is I'm gonna just end the session in terms of us talking about 7-7. And don't worry about the homework for it tonight. I mean, if you want to try it, you can, but there's stuff we haven't done. I would focus on the exam. So I will take the next 5-6 minutes of class to answer any questions that you may have on the exam. If you're comfortable, I'll talk about the review if you want me to talk about the review. If there's anything you need me to discuss, I can. If not, and you're happy, then I will see you on Wednesday at 9 a.m. sharp.
Thank you, sir.
Okay.
Okay.
I'll just hang out here if you have a question.
Real quick, I think you might have said this earlier, but I can't remember. Are we going to need to put any domain or range for the exam?
For sine and cosine, I don't think so. I just want the graph. I think domain and range is going to be something I test you on later, so I'm not concerned about it. I mean, the sooner you learn it, the better, but don't worry about it for this exam.
Okay, because it's still not something I fully understand how to do and feel comfortable with.
Okay.
So I just need to know if I needed to like study
Yeah,
that.
well, for
and make sure I
sine and
understand it before
cosine,
Wednesday.
for sine and cosine, domain is always just all real numbers. And the range is just the amplitude. It's negative to positive, whatever the amplitude is. So for sine and cosine, which is all we're doing on this test, it would be a pretty straightforward thing. Once you get to secant and cosecant and tangent and cotangent, that's when things get a little weird.
Yeah, like the infinity part confuses me.
Yeah. Yeah, so I wouldn't focus too much on that right now.
Okay. Then yeah, I won't worry about that too much.
Yeah.
Before Wednesday.
Okay.
I
What
had a
else?
question
Mhm.
about problem 11 on the review. Just wanted to clarify that what we're trying to find there is we're trying to find the arc length, correct?
Correct.
Okay.
That's right. I thought you were going to ask me what kind of dog it was, but I guess that's not relevant.
And as long as we're like comfortable with the study guide, we should be okay on the test.
Yes, but you know, I always have to, you always have to remember that what I mean by that is not only that can you do this, but you know, can you do it in the time that I'm giving you, right? So this is about problem recognition also. So it's about looking at the problem, knowing what to do when you see it, and then executing that. And so it's not only can you do it, it's can you do it efficiently and in a timely manner. But I won't stray away from it. The concepts here, what I don't want people to do is be like, you know, okay, he gave us this problem, so he's going to give us exactly something like that. No, the idea here is that you should be able to do partial fraction decomposition. That's what I'm going to test you over. It's not going to be guaranteed to be a problem just like this and just like this, and I just change a few numbers. That means you have to review everything we did in class, make sure you understand it. So I guess my answer to your question is kind of yes and no. You should feel good if you can do the review. You should feel good about it, but don't limit yourself to just doing the review. Go back and look at your homework, look at the problems we did in class. What else? Are you all nervous? Are you feeling good?
Yes, I'm nervous. You said the test was going to be shorter than the review?
Yeah, I don't think that anyone could complete this review in an hour and 20 minutes. I think it'd be
an
tough.
hour and 20 instead of an hour and 40?
Well, it's because we're going to take so much time in the beginning with everyone copying problems down and getting their cameras set up. We're going to lose a lot of time doing that.
Okay.
Yeah.
Okay, you had said we were going to need to copy it down. Can we print it? Is there going to be a way to do that?
You can.
Okay,
I'm just going to send you a PDF copy of the exam. If you have a printer, do you have a printer?
I do.
Yeah, you can just print it. But even if you
just trying
print
to
it,
do
you
that.
still have to wait. You have to wait. You can't start the test.
Okay.
You have to wait for everyone else to copy it down. That's just to be fair.
Okay.
Yeah. Any others?
I had a question about the calculator.
Yes.
So like the TI-84, that one's good, right?
Sure.
Sweet. Thank you.
Is that what you have?
Yeah.
Yeah, just make sure you remember how, how to switch from degree mode to radian mode, right? Because there's several, well, there's at least one question on the test that requires your calculator. Like for sure, this one right here, you had to be able to figure out what tangent of 12 degrees was on your calculator. So you had to be in degree mode. So just make sure you understand how to do that.
Yes, sir. Thank you.
Mm-hmm.
Would it be acceptable if I logged in on both the camera I was using and my computer just to be able to print the exam and then log off of that so I only have the one that's showing me?
Yeah, because in the first 15 minutes when you're writing the test down and all that, I
Mhm.
don't care if you're even on the camera. Like
Okay.
you're just like, you do what you need to do to get a copy of the exam written down. Once the test starts, I would prefer it just be one account. And
Yeah, well, I'll log off of my computer completely and I'll have the one that will be filming me.
yeah, that's fine. I mean, I don't mind two camera feeds, but I start to lose track of who's who because most people that when they come on with two cameras, they have different names on the cameras. Like one of them will be like your name, the other one will be like iPhone. And so I don't know who iPhone is. And so it's just better if it's just one camera. But during the copying of the problems, you can have two. That's fine.
Okay. Thank you, sir.
You're welcome.
Have
Maddie,
a good day.
you too. Are you good, Maddie?